Before we get into any details, let's start with a brief introduction. What statistics is? Well, statistics involves asking questions. Now, it's not a question such as, what is the capital of Vermont, which happens to be Montpelier, but it's asking questions that we don't have the answer to, and that it can help us by collecting data to address some of those questions. So the first thing is asking questions. And generally, we call those questions research questions. That's what we're always going to look back to figure out how we set up our study, what questions we do ask, and it helps us to identify the variable, which we'll talk about more soon. Then the second step is we want to collect data to address the question that we have. We then analyze the data. So it's not just enough to get data, but then we have to analyze it. And we're going to be doing some of that in this class. Then we're going to draw conclusions from the data. You may find conclusion that it's more likely that fill in the blank will happen than something else. It's not just enough to draw those conclusions, though. Then we have to communicate those results to the people who are interested in the results. So we need to clearly communicate what we found in our study. Before we get started with anything else, what we really need is a common language and some skills with probability. So I want to make sure that we're all on the same page. Some of you may have taken statistics before and use slightly different vocabulary. So we're going to focus here, this first note set, on getting a common vocabulary so that when I say something such as categorical, when I'm speaking in relation to a variable, you'll know what that means. So let's start off with some basic definitions. Observational units in a statistical study are the objects described by a set of data. You'll frequently see me write observational units instead of writing out the full observational unit, I'll just say OU. They're what we're going to look at. It can be people. Examples include people, animals, things. They can be animate, in other words, animate, moving, or inanimate objects. For example, the color of a pen. Is it red or blue? Okay. Is it going to vary pen to pen? Yes. And you're like, well, where did variable come from? The next point. A variable is any characteristic of an observation unit which can take different values for different observational units. So for instance, if I have in my bag 5 different pens, they can vary. Obviously, I carry different color pens with me. One thing that'll vary is what color the pen is. Some of my pens are blue, some are black, some are purple, some are green. I'm not a big red person myself, but one thing that'll vary will be the color. So the observational unit that I'm looking at here is each pen. One thing that varies is the color. Think for a moment, can you come up with something else that could vary from pen to pen? Well, the one thing that came to my mind is the manufacturer. Who are these pens by? Some may be Bic, some may be Uniball. Different manufacturers or different sellers of pens. So that would be another characteristic that would change from pen to pen, who manufactured it. Now, there are 2 types of variables that we're going to be looking at in this class. Variables that take on numerical values for which ordinary arithmetic operations make sense are quantitative. Okay, so for instance, if I took the age of everyone who's in a room and I added those ages up and I divided by the number of people in the room, we would get an average age. So that makes sense. On the other hand, what if I took everyone's social security number and said, okay, I'm just going to take the first 3 digits of everyone's social security number, add them up, and then divide by the number of people in the room? Does that tell me anything? Actually, it doesn't. I mean, that's not meaningful in any way. I'll talk more about social security numbers in just a moment because we're going to talk about variables that take on category designations, and they're called categorical. If you've taken statistics before, or if you may have heard that this is also called qualitative. So instead of quantitative, there's also qualitative. In this course, I use categorical. So a category, it can take on different categories. So what do I mean? Social security numbers. So where I grew up in Vermont and in the New England in general, we have mine starts with 008. Well, when I first moved to California, someone asked me if I was dead, and I'm thinking, that's a weird one since I'm standing right here. Well, they'd never seen anyone with a 008 as the first three digits of a social security number. So that identifies me actually as coming from New England. A category, a very specific type of categorical variable, is one that only has two categories, and we refer to as binary. So for shorthand, you'll frequently see me use Q for quantitative, C for categorical, and binary, I'll either do B or NB to be either binary or non-binary. So for instance, if I asked, okay, I've got 5 pens and I have various colors. Would that be what would vary from pen to pen? Well, we've talked about that earlier. The color would vary. Would it be binary? So it's categorical, but would it be binary? No, I had multiple colors. But what if I held up a pen and said, is this blue or not? Well, is that categorical in nature? Categorical, obviously, yes, excuse me. Is it binary in nature? And the answer is yes. It's either blue or it's not blue. So I think about these as yes or no questions, or it could be answered by yes or no. So let's do an example. For each of these questions, they did lead to statistical studies. For each one, we're going to identify the observational unit and the variable. So the first question, how much did a typical American consumer spend on Christmas presents in 2020? Alrighty. Well, we're asked to identify the observational unit and the variable. Who are we looking at, or whose behavior are we looking at? In this case, hopefully you'll see, well, it's a typical American consumer. So what we want to do is we want to look at each. And you'll notice in this class that I emphasize that for observational units and for experimental units down the road, what I want to do is record information on each one of them that I take in a sample, which we'll talk more about down the road, like I said. So we have each American consumer. Could I have said each typical American consumer? Sure. Could I say each American? No, because not all Americans are consumers, and we're interested in the American consumer. What's going to vary from American consumer to American consumer that we're interested in studying? Well, let's see. Oh, it's the amount they spent on Christmas presents in 2020. I don't ask specifically, but let's identify, is this variable categorical or quantitative? Well, let's think about it. We're saying we're going to record the amount that someone spent. Let's say they spent $500 on Christmas presents in 2020. Is that a category? No, we can take each person's amount, add them together, and divide by the number of people that we've collected the data on, and that would give us an average. So that makes sense. It's quantitative. On the other hand, if I had said, did the typical American consumer spend more than $500 in 2020 on Christmas presents? The person would be asked, did you spend more than $500? And the answer would be yes or no. That would be categorical. They're not going to give you a number necessarily. They're either going to say, yes, I spent more than 500, or no, I didn't. Hopefully you'll also notice, so that takes care of that example. But what I want you to notice with the variable part, I took as much information as I had, amount spent on Christmas presents. Why is it important that I said in 2020? Well, that's what we're interested in. We're not interested in just, it would be very different if we looked at 1987, for instance, versus 2020. Obviously, COVID affected things. So after COVID, the amount spent on Christmas presents may have gone down. It may have gone up. People may have been overcompensating. So we want to be careful and give as much information as we have. Now, we don't want to give more information than we have we don't want to make things up, but we want to make sure that our answers are complete. Next one. Do more than half of all Americans support universal health care? Please take a moment, pause the video, and see if you can come up with the answer. I would start by writing OU, and then what it is, and then variable. Okay, hopefully you took a moment and paused. We're interested in, do more than half of all Americans support universal health care? So we're looking at all Americans. So we're interested in each American. Did it say specifically adults? No. Could we ask school children this question? Certainly. So we want to be careful. We don't want to say each American adult because it's just asking half of all Americans. Now, do more than half support universal health care? What's varying from person to person? Well, it's whether they support universal health care. That's what's going to vary from American to American, from each observational unit to the other observational unit. What varies is whether or not they support it. Now, you either support it or you don't. If you look at this, you may be like, well, what if they're indifferent? We're not doing indifferent unless it's very clear in this survey, or people asking this question would say, do you support it or do you not? So it would be yes or no. There is no, obviously, hopefully you can see there's no values for which arithmetic operations would make sense. So it is not quantitative. It is by default categorical. And I didn't ask specifically, but is it binary or not binary? It is binary. Either you support it or you don't.